Hello everyone, in this video we're going to look at the negative binomial distribution. In the previous video we have a look at binomial distribution. Negative binomial distribution actually is very similar. Binomial distribution is, for example, let's just review a little bit of what is binomial distribution. Okay, binomial distribution is, for example, for particular class, the one student to pass the class, the probability is, for example, 90% he can pass the class, or there's 10% the student cannot pass the class. Now, if I have 10 students, randomly selected 10 students, okay, 10 students or just 20 students in the class. Now the probability of 15 students will pass the class. So you're going to have x equals 15. 15 students will pass the class. Well, we don't know which 15, so we select 15 from 20. And then 0.9 to power 15 and 0.1 to power 5. Okay, this is the probability that the student will not be able to, 5 will not pass, 15 will pass. This is the binomial distribution. What is the negative binomial distribution? Negative binomial distribution is, for example, when I grade the test paper, well, I know that probability of a student will pass this test is 0.9, 90%, or student will not pass the test is 1%, sorry, 10%. Well, when I grade the test paper, the 10th student okay, so it's the 10th student, the 10 students will be the 15th one. Okay, sorry, I can't do the 15. The 10th students, when I check the 10th test, not 10 students, well, 10 students test. I grade one by one. Okay, is the probability of the 10 students is the 8th one to pass. Does it make sense? The 10th student test is the 8th one to pass the class, which means during the previous 9 tests, I have 7 have already passed. Okay, so the previous 9, you have already have 7 passed. Okay, previous 9 tests, I have already have 7 passed, and the 10th one will be the 8th one to pass. That's the probability. The previous 9, I don't know which 7, but we have 7 out of 9. Okay, and 7 passed is 0.9 to 7, and the 2 did not pass is 0.2 or 0.1 to square. And then the last one is the 10th one. The 10th one is the 8th one, 10th one to pass, so it's 0.9 again. Okay, that's the negative probability distribution. We will have several examples later in the homework. Okay, so the Poisson distribution. The Poisson distribution is given as probability of x lambda t equals e to negative lambda t to power x over x factorial. Okay, u equals lambda t. Okay, this is the mean value and also the variance. Okay, so let's look at an example. During a laboratory experiment, the average number of radioactive particles passing through a counter in a millisecond is 4. What is the probability that 6 particles enter the counter in a given millisecond? So now mu equals 4, so equals 4 for this one. Example 5.17. So just look at the number is x4. You plug it in. So now the number t equals 4, so the e to negative 4, and you have the 6 particles will pass, so it's 4 to power 6 and 6 factorial. You can use the calculator to do this, or you can use the distribution table to work on this. The distribution table, we're going to see in the homework, you're going to have from 0 to 6, power x to 4, this will be given in the table, minus the probability of accumulative from 0 to 5, probability x4, okay? So both of these will be given from through the table. We just need to subtract it, okay? The probability 0, 1, 2, 3, 4, 5, 6. Probability 0, 1, 2, 3, 4, 5. You subtract it, it's just the probability of x equals 6. Okay, does it make sense? Alright, so you can watch the, read the whole textbook. I think it's very important for you to read the textbook, then you continue doing the homework, okay? Let's look at the homework next. Okay. First question is uniform distribution. You can do that yourself. I think it's pretty simple. It's a uniform distribution. The x is just the 1 over 14 because I have 14 numbers. You random pick up one is 1 out of 14. Now the probability of x is less than 10. Basically have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or is less than 10, you only have 9. So it's 9 out of 14. For uniform distribution, that's pretty simple one. Okay, the second one, in the next 5 theft cases report in the district, next 5, exact 2 result from needing money to buy drugs. So you have px equals 2. Basically select 2 from 5. Okay, 2 will need the money to buy drugs, so it's 0.58 square. Okay, then the 0.42, the probability that they don't need money result from not buying drugs is 0.42. Okay, buy drug is 0.58, not buying drugs 0.42. And I have 3 other person not using the money to buy drugs. That's the probability of this one. You can use the calculator to do this. So first one, this is 5 factorial over 2 factorial minus times 3 factorial. 5 minus 2 factorial. Okay. You can change this into 5 minus 2 factorial. Okay. Then this is 5.58 square times 0.42 and cube for this one. Okay. So the next one, px less than equal to 3. This will equals px equals 0 plus px equals 1 plus px equals 2 or plus px equals 3. Okay. So we got px equals 2. You just need to find the other 3 and you find it. Or you can do px less than equal to 3 equals 1 opposite event or complement set is x bigger than 3. Bigger than 3 is 4 and 5 because you only select 5, right? So px equals 4 minus px equals 5. What is px equals 4? You select 4 from 5, okay? And then 0.58 raised up to 4th power times 42 raised up to 1st power minus choose 5 and 0.58 to power 5 times 0.42 and 0 power. So this one equals 1 minus 5 times 0.4 minus 0.421 minus 0.58 to power 5. Okay. Then you use the calculator, find that is 0.7697. Next one. The probability, this is the binomial distribution, but the table will be given to you, the cumulative table. The probability from 3 to 6 have blowouts, 3 to 6, and the n equals 16, p equals 0.3, and it's from 3 to 6, okay? X from 3 to 6. The probability from 3 to 6, you can write that as px less than equal to 6. bigger than equal to 3. This actually equals from x equals from 0 to 6 probability, okay, of 16, I think it's 0.3. You do that, okay, then you can write 6, but it's not really a big deal. You just write down this is it's just a probability of polynomial distribution, and then this is just the parameter numbers. Probability from x to 0 to, since the 3, 4, 5, 6, so you have subtract 0, 1, 2, so it's from 0 to 2, the same probability, okay. Alright, so the rest of them you can use the table to find the rest of them, okay. So the rest of this one is going to be so we will have the from 0 to 6 probability equals 0.3. So we check from n equal 16. So let's go to n equals 16. This is 14. We need a 16. So it's the page 2. Okay, so page 2 and n equals 16. So this is the n equals 16. N equals 16 right here. Okay. So and also check p equal 0.3. 0.316. 0.316. 0.3 is this one. 16 to 6. So it's 0.8247. So it was 0.8247 minus from 0 to 2. 2 is 0.19. 0.36. Wait, 0.36 is 0.27, yeah. And then go to 2 is 0.0994. 0.90994. Okay, then if we subtract it, it's going to be equal 0.7253. Okay, now let's see the probability of x is fewer than 4 is less than equal to 4, which means you just directly read from x equals 0, x equals 0 to 4, and p of 16 and 0.3 and x. Okay, so you can do that and you read from the table. So less than equal to 4, so 16.4 is 16.4 goes to 0.3, 16.4.3, 0.4499, 0.4499. Okay, it's in the, you go to 16, then go down 4, and it goes to 0.3, it's 0.4499. That's how I do this one. Wait, less than, fewer than 4 trucks. Okay, fewer than 4 trucks. Fewer than 4 trucks. Fewer than 4 trucks is just a 3, not equal 4. So just from 0 to 3. So just a 3 is 0.2459. Okay, 2459 because it's a less than equal to 3. Okay, so next one is that more than 5 trucks. Okay, px is bigger than equal to 5. More than 5 trucks is bigger than 5. So which is 1 minus p x less than equal to 4. Okay, so 1 minus, we find a 4, 16, and a 4 goes to 0.3. 0.3 goes to 4, 0.4499, 0.4499. Subtract is 105.5501. Okay, so it's going to be 0.5501. Let me double check it again, this one. So it's 16. You see, so it's more than 5, so it's bigger than 5, less than equal to 4, 1 minus that, that's right. So it's 16.3 goes to 4, 0.4499, 0.4499, so 1 minus 0.0000.4499, so this is 1065, 56 or 01. Okay, it's 0.5601. So which is 5601. Wait, is 1, 9 minus 9 is 0, 0 minus 6, and 1 minus 4. It should be 5, 0.506.1, 65. Let me double check it again. It's more than 5 trucks, so it's bigger than 5, but bigger than 5 is 1 minus p x less than or equal to 5. My bad. Okay, so bigger than 5, then it's less than or equal to 5. Okay, so there's a mistake here. And bigger than less than or equal to 5 is 6598. 6598. The answer is going to be 3502. Let's do it. Okay, so 3502. Oh, 3402. My gosh. Okay, 3402. Next one, but this is how you do that, right? Okay. And the next one is testing a certain kind of truck tire over rugged terrain. It is found that 20% of trucks fail to complete the test run without blowout. Of the next 12 tested, how many of them would expect you to have blowouts? So 12 times 20%, which is mu equals MP, and which is 2.4. Okay, that's the mu. And then we also have the sigma variance. Okay, the variance is MPQ, so equals 12 times 0.2 times 0.8. So the answer is going to be 1.92. This is the easy one. Okay, so next one, let me see. Next one is polynomial distribution. You have formula. First is the formula is C. The next one is the formula calculate probability. So basically you find out P over 6 equals what? Equals, you select 6 will be due, by using the formula 6 will be due mainly to violation. Okay, so 6 is choose 6 from 10. And probability is 0.4, 4 out of 10. So 4 out of 10 is 0.4. P equals 0.4, Q equals 0.6. And power 6, and the rest is 0.6 to 10 minus 6, which is 4. So the probability is 10 factorial over 6 factorial times 4 factorial times 0.4 to power 6 times 0.6 to power 4. Okay. The power add together is 10, and these two probability add together should be 1. And together the answer is 0.01115. Okay. You can also use the table to do it. So how do we use a table to do it? Is because it's asking for 6, you just use px less than or equal to 6 minus px less than or equal to 5. So then it's going to be just a 6. So let's read the paper. So the n is what? N is 10. N is 10. The first one doesn't have 10. So let's read the second page. The second page have 10. So let's go to 10. So 10, the probability is 0.4. 0.4 is this line. So this line, 0, 1, 2, 3, 4. So it's 10 to 4. And go to 6. So it's 0.952. 9452. 0.9452. 0, 1, 2, 3, 4 is go down to 6. Okay. Then minus 5. Minus, when x equals 5 is 0.8338, the probability. You subtract those two, it's going to be 0.1114. Okay, that's number 5. Let's go number 6. Number 6. So for a lot of 15 missiles, 5 are selected and random are fired. Suppose the lot contains 3 defective missiles that will not fire. So 3 defectives, 3 not fire. Okay. And we have 15, so 12, okay, will fire. So we choose 5. 5 are selected. Now the probability that 5 missiles will fire. So all 5 will fire. So it's 5, select 5 from 12. Then select 0 from 3 will not fire. And the total is 15. And select 5 from 15. Then how do you calculate it? So this one equals, okay, this one equals 12 factorial over 5 factorial, 12 minus 5, 7 factorial times 1. The bottom is 15 factorial over 5 factorial times 10 factorial. You can use a calculator. Your answer is going to be 0.2637. Okay, that's how you do the first one. Okay, how to do the next one? At most 2 will not fire, so it's going to be 0 not fire, plus 1 not fire, plus 2 not fire. Okay, so how about 0 not fire? 0 not fire means 5 will fire. So this is 0 not fire is 5 fire. 1 not fire, so it means 4 will fire. 2 not fire means 3 will fire, because to get total is 5, right? So now we choose it. We have 12 will fire, so select 5 from 12. And then select 0 from 3. And the total is the same. Choose 5 from 15. Plus 1 will not fire, so 4 fire, so choose 4 from 12. We have 12 will fire, right? 3 will not fire. And choose 1 from 3. And choose 5 from 15, which is the total. And then 2, the next case is 2 not fire, so it's 3 will fire, choose 3 from 12. And 2 will not fire, choose 2 from 3, because we have 3 not fire. And bottom is the total is choose 5 from 15. You add all of this together, and then you can get the second one, okay? Next one is number 7. Problem 7 is suppose 6 cards are dealt with from an ordinary deck of 52 playing cards. What is the probability that exactly 4 out of 4 cards will be faced cards? 52 cards. How many face cards do we have? 12 face cards. Okay. And the 40 just numbers. Numbers were 8s, right? 40 non-face cards. Now we're making the probability. So probably exactly 4 face card. Okay, so we have 12 face cards. And we choose 4 from 12. And then suppose we have 6 cards, so the rest of 2 will not be, the rest of 2 will be non-face cards. The rest 2 will be selected from the rest of 40 cards. Total sample space, just randomly choose 6 from 52. Okay, so if you use a calculator, do that, is 12 factorial over 4 factorial times 8 factorial times 40 factorial divided by 2 factorial times 38 factorial. The factorial is in your, you can use a calculator to do the factorial, okay? The bottom is 52 factorial over 6 factorial. 52 minus 6 is 46 factorial. Okay, then this answer will give you 0.0190, okay? And then probably at least one of the cards will be a queen. So how many queens do we have? We have 4 queen cards. And the rest of 48 non-queen, okay? No, not queen. All right, so it says at least one of the cards will be queen. We can use at least one. It equals 1 minus 0 queen. Okay. At least the queen means 1 queen, 2 queen, 3 queen, 4 queen, okay? Well, the complement set is 0 queen, okay? So what's the meaning of that is, we use 1 minus, complement set is 1 minus 0 queen. So we choose 0 from 4. and choose all 6 from the rest of 48 cards. And the total is 52 and 6. Okay, and then the answer will be 1 minus 48 factorial over 6 factorial times 42 factorial divided by 52 factorial over 6 factorial times 46 factorial. So use a calculator, you can get the answer is 0.3972. Okay. Next one. Find the probability that dealt with the hand of 14 cards contain 4 spades, 3 hearts, 2 diamonds, and 5 clubs. For each one, we have 13 cards. Okay, 13 spades, 13 heart, 13 diamond, 13 clubs. Okay, so together it's 52. So now it says containing 4 spades. So you choose 4 from 13. And contains 3 hearts. Choose 3 from 13. Contains 2 diamonds. Choose 2 from 13. Contain 5 clubs. Choose 5 from 13. Okay. Then the total sample space probability X, okay, equals that. Okay, equals. Total sample space is 52. Randomly select 14 cards. Okay, that's how you do it. And then you can find that answer yourself and see what that is. Okay, so the top is 13 factorial over 4 factorial times 9 factorial times 13 factorial 3 factorial times 10 factorial times and 13 factorial over 11 factorial times 2 factorial. Okay, and times 13 factorial over 5 factorial times 8 factorial. Okay, you have 4, all of them multiplied together. Okay, find each. It's better you find one number, write it down. Find another number, write it down. Find this number, write it down. Find this one, write it down. And then the bottom, find the number, then write it down. 52 factorial over 14 factorial times 38 factorial. Okay, then this will give you the answer for this problem. Number 9 is pretty much very similar. Okay, let me see. A urine contains 5 green balls. 5 green balls. It's 5 green, 2 blue, and 4 red. In a random select 5 balls, find the probability that both blue balls and at least 1 red ball are selected. At least 1 red ball are selected, which means you got 5, right? 5, at least 1 is selected. So at least 1 means 1, 2, 3, 4, because that's the total thing, right? So now we have both blue will be selected. So at least we have 2 blue, and then we have blue. So 2, all of 2, and at least 1 red. So the 1 red selected from how many red we have? 4 red ball we have. So select 1 from 4. Now we have the rest is what? We have 2 remain because the total is 5. Total is 5 ball, right? So we have 2 blue, 1 red, and the rest, the 2 will be green. Green was selected from 5. And divided by the total is 5 plus 2 plus 4 is 11. Select 5 from 11. Plus, and we have 2 blue, 2 blue. And now we have 2 red from 4. And then we have 1 green from 5. And also 11, choose 11 from 5. Choose 5 from 11. Okay. And plus, and 2 out of 2 blue. And choose 3 red from 4. And 0 from 5. 0 from 5 actually is 1. The number is 1. And 1, select 5 from 11 from 5. So that's the probability. Now we can calculate it. The top should be very simple. Choose 2 from 2, that's one option. You have to choose all of them. So it's one option. So it's 1 times, choose 1 from 4. You select 1 is 4 options. Okay, 4 factorial over 1 factorial over 3 factorial. So you have 4. 5, choose 2 from 5. You can do 5 times 4 over 2 times 1. Okay. This is the same idea as 5 factorial over 2 factorial over 3 factorial. They are exactly the same thing. You can do 5 times 4 over 2 times 1. Choose 2 numbers from the top, 2 numbers from the bottom. Okay, plus 2, choose 2 from 2 is 1 option. Choose 2 from 4, which is 6 options. Choose 1 from 5, you have 5 options. Choose 2 from 2 is 1. Choose 3 from 4 is 4. And choose 0 from 5 is 1. The bottom is 11 factorial over 5 factorial over 6 factorial. Okay, so the answer should be 1 times 4 times 10 is 40 plus 30 plus 4 over 11 factorial over 5 factorial over 6 factorial. You can use a calculator to find this. Okay, so that's how you do this one. Is going to be the probability. Number 9. Or number 10. The probability that a person lives in a certain city owns a dog is estimated. Its probability is 0.15. Find the probability that 11th person randomly interviewed that the city is the 4th one own a dog. So 11th one is the 4th one. Okay, 11th person is the 11th sample. You can say person or sample. Is the 4th one owns a dog. What's that mean? That means before 11 people, before the 11th person, we have already did 10 interviews. We have done 10 interviews. Out of the 10, 3 own a dog. Because the 11th one is the 4th one. So before 11, we have 3 own the dog, right? 3 owns the dog. Okay. So 10 interviews, 3 owns a dog. The 7 does not own a dog. It's a binomial distribution. So you choose 3 from 10. You own a dog. The probability owns a dog is 0.15 to 3. This is the 3, so third power. Multiplied by not own a dog is 0.485 because together is 1. Okay, own a dog is 0.15. Not own a dog is 0.85. And then raise up to the 7 people doesn't own a dog. And then the next one, the 11th people said owns a dog is 0.15. Okay, then you find that the probability is going to be 0.0195. Okay, you can use a calculator to do that. How you use the calculator to do that? This is going to be just 10 factorial over 3 factorial over 7 factorial multiplied by 0.15 cubic power times 0.85 7th power times 0.15. You can use a calculator to find the numbers one by one, then multiply them together. Okay, so you get this. Number 11. A scientist inoculate mice one at a time with the disease germ until he finds 3 that have contracted the disease. If the probability contracting the disease is 1 out of 9, what is the probability that 7 mice are required? Okay, 7 mice are required, which means the seventh one is going to be the 3rd one get the contact the disease. So before the 7th one, we have already had 2. Okay, before the 7th, so previous 6 mice, there have already 2. Previous 6 mice, 2 have already contacted. Okay, so basically you have is negative geometric negative binomial. So you choose 2 from 6 because before the 7th one, before the 7th mice, 2 have already contacted the disease. And we have 6, before 7 is 6 mice. Okay, out of the 6 mice, 2 has already contacted. So probability have contacted the disease is 1 over 9 square. Not contact disease is 8 over 9 and raise up to 4. But the next one, this is the 7th one. This is for the previous 6. The next 7th one will contact disease is 1 over 9 again. So this probability will equal 0.0128. How do you use a calculator to do this? You use a calculator to do 6 factorial over 4 factorial times 2 factorial times 1 out of 82 times 8 power 4 over 9 power 4 times 1 over 9. Use the calculator to do that, which should not be a big problem. Okay. For on average, 4 traffic accidents per month occur at a certain intersection. Complete parts A through C below. So this is the Poisson distribution. What is the probability that exactly 6 accidents will occur at any given month at this intersection? So basically we have Px equals 6. This table will give you from 0 to 6. Okay. And also, it will give you, you can find from 0 to 5, okay, probability of X. Okay. You can find from 0 to 6 minus from 0 to 5 accumulated. So then it's 0, 1, 2, 3, 4, 5, 6, the probability of those. 0, 1, 2, 3, 4, 5, the probability of this. If you subtract those, then you only have a probability of X equals 6, right? So let's look at the table. It says average is 4, which we got, the mean value is 4, so R equals 4. Okay, so let me see. It says mu equals, mu equals 4. Let's say mu equals 4. Now, it says 4 traffic accidents per month, right? 4, it goes to 4 is this line, mu equals 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0. So that mu equals 4. Now, mu equals 4, and what's the R? It's 6, right? 6. Now we find 6. 6 goes to 4 is 0.8893. Okay. 4.0 go down to 6. So it's 0.8893. Minus from X equals 5. So accumulated 5 is 4.0 goes down to 5. It's 0.7851. 0.7851. Which give you the answer is 0.1042. Okay. Number B. What is the probability that fewer than 4 accidents? Fewer than 4 accidents means X is less than equal to 3. Okay, not X equals, is actually P X less than 4, but it's just a 0, 1, 2, 3. So from X from 0 to 3, the probability of that, and which equals, we just use that table again, is still 4, go down to 3. So it's goes to R equals 3, mu equals 4. It's 0.4335. Okay, that's how you do that. Number C. What is the probability that at least 3 accidents will occur at any given point? So at least 3 means Px bigger than equal to 3. We can use the opposite event. It's P minus X less than 3. And then this is 1 minus P X less than equal to. So we can use the table 1 minus from X equals 0 accident, 1 accident, 2 accident. So from 0 to 2. And the table will give you the cumulative from 0 to 2. What do we need to just find from mu equals 4, still mu equals 4, R equals 2. So it's 0.2381. Okay. 4.0 go down to R equals 2, 2381. Subtract it, give you answer is 0.7619. Number 13. On a certain region of a country is on average hit by 5.5 hurricanes a year. Okay. What is the probability that the region will be hit by fewer than 4 hurricanes at a given year? So average is 5.5, which is mu equals 5.5. It asks you P, well, you can do R or X. Normally we just use X as a random variable, okay? So X less than, fewer than 4 is at less than 4. And equals P is X less than equal to 3. So we use the table, we can find X equals 0 to 3, accumulated probability of X. Okay, let's use the table. We go to mu equals 5.5 is the first clone. Mu equals 5.5 first clone. And X from 0 to 3, just go to 3, which is 0.2017, because that 3 means accumulated. Okay, this distribution is the probability sum. So accumulators from 0 to 3, you just find the 3 numbers, just exactly this number of 0.2017. Next one, the probability that x will hit from 2 to 6. So bigger than equal than 2, less than equal to 6. What do we do is just use px less than equal to 6 minus px less than equal to 1. So basically 0, 1, 2, 3, 4, 5, 6 minus 0, 1. You have 2, 3, 4, 5, 6. Okay. So let's go to 6. 6 is 0.6860. And I go to 1, which is 0.0266. The probability is 0.6. R mu is still 5.5, the first column. So R equals 1 is 0.0266. R equals 6 is 0.6860. You subtract it, it's 0.6594. Okay, so last question. The average number of field mice per acre is in a 6-acre wheat field is estimated to be 15. So get the average mu equals 15. Okay, find the probability that fewer than 14 field mice are found on a given acre. So fewer than 14, so which you got px less than 14, which is px less than equal to 13, which is from x equals 0 to 13 and probability of x. Okay, you can do 15x, well, just the notation of that. But as wait a moment, it's x15, right? x15 is the mu, is the parameter. So we use the table. Mu equals 15, 1, 2, 3, 4, 5, 6. The 6th column, okay, we go down to 13. 6th column, so this one, go down to 13, which is 0.3632. 0.3632. Let's just directly find it. Okay, the column, 1, 2, 3, 4, 5, 6. 6th column, go down to R equals 13. You get the number 3632. Next one. The probability fewer than 14 field mice are found on 3 of the next 4 eggs inspected is what? So 3 of the next 4 eggs, we got the probability per a given one. The probability is fewer than 14. The probability given is 0.3632. Now, 3 out of next 4 is a binomial distribution again. And the Q equals 1 minus 3632. Now, for the problem B is a binomial distribution again. 3 out of next 4, we don't know, okay, which 4, which is 3, but it's 3 out of next 4. Next 4, probably the first 3, second 3, the middle 3. So choose 3 from 4. And the probability of we find in less than 14 mice is 36, 32 point, and raise up to third power. And we have 1 which is not less than 14, so it's 0.1 minus this probability raised up the first power. So you got to answer is 0.1220. Okay, so that's how you do this problem. It requires you to do some analysis. So I want you to think about the problem, read the textbook, and think about why it's like that, and do a similar exercise. I try my best to understand the problems. Okay, we're done here.